Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have 8 to the power of n plus 2 to the power of n equals to 68, and we solve this problem for the values of n. So here the very first step we are going to do is, here first we write this 8 as 2 cubed. We know that 2 cubed equals to 8 and its whole power n, plus this is 2 to the power of n equals to 68. And now in the next step, here we need here we use the rule of interchange, and you know about this rule of interchange. If we have a to the power of m to the power of n, so this rule of interchange just tells us that we interchange these two exponents and we write it as a to the power of n to the power of m. So it is always gives us the same answer, and it is equals to a to the power of m times of n. So here, according to this rule of interchange, we interchange these two exponents here, and after interchanging these two exponents, we write it as 2 to the power of n and its whole cubed plus 2 to the power of n equals to 68. And now next further we just take here our this base 2 to the power of n is it is same, so we take it equals to y and we write it as y equals to 2 to the power of n, so that when we substitute this 2 to the power of n equals to y, so that our above equation is written as in this form: y cubed plus y equals to 68. And now in the next step, here we move the 68 in the left hand side, and it is written as y cubed plus y minus 68 equals to 0. And now in the next step, here we just we need to solve this cubic equation, and we have many ways or many methods to solve this cubic equation, so that here we just break over this minus 68 and we use the cubic formula in order to solve this problem. So here we rewrite this 68 as in this form: y cubed plus y minus 64 minus 4 equals to 0. We write this minus 68 as minus 64 and minus 4. And now in the next step, here we make the pair of y cubed with the 64 and we make the pair of this y with 4. So after pairing these, we get y cubed minus 64 and plus y minus 4 equals to 0. And now in the next step, here we rewrite this equation as, so this is y cubed and minus this is 64, and we write it as 4 cubed and plus this is y minus 4 and this whole equals to 0. And now in the next step, here we use the nice cubic formula, and you know about this formula: if we have a cubed minus b cubed, it is equals to a minus b times of a square plus ab plus b square. So here we use this nice cubic formula to the above equation, so that our above equation is written as in this form. So this is y cubed minus 4 cubed. So when we use this formula, it is written as y minus 4 times of y square plus ab. So our a is y and b is 4, and plus b square, so b is 4 square, and this is equals to 0. So here further we need more simplifications of this equation, and when we make simplification, it is written as y minus 4 times of y square plus 4y plus this is 4 square is 16, and this whole equation equals to 0. And now further we divide this equation into the two cases, so that our first case is we take y minus 4 equals to 0, and the second case is we take y square plus 4y plus 16 equals to 0. So now in the next step, here first we focus on this case, and here we have y minus 4 equals to 0, and here we get easily the value of y equals to 4. And now we back substitute this value of y, and in the start of the problem we will take here our y equals to 2 to the power of n equals to 4. So this implies that we have 2 to the power of n equals to, we write this 4 as 2 square, and we know that the bases on both of the sides are same, so that we equate its exponents and we get here n equals to 2. So this is our first real solution of the given equation. And now in order to find the other solutions, we need to solve this quadratic equation. And now here we copy down this equation here: y square plus 4y plus 16 equals to 0. So here we use the quadratic formula in order to solve this quadratic equation, and here we have the coefficients of this equation are a equals to 1, b equals to 4, and c equals to 16. And we know about the quadratic formula. It is stated as minus b plus minus square root of b square minus 4 times of ac, and it is divided by 2 times of a. So here we substitute the values of a, b and c in this quadratic formula, and it is written as in this form: y equals to minus b, and the value of b is minus 4 plus minus square root of b square, so b is 4 square, minus 4 times of a is 1 and c is 16, and it is divided by 2 times of a, and our a is equals to 1. And now in the next step, here we have minus 4 plus minus square root of 4 square becomes 16, and minus 4 times of 16 equals to 64, and it is divided by 2. And here when we subtract 16 by 64, it is written as minus 4 plus minus square root of 16 minus 64 equals to minus 48, and it is divided by 2. So here we rewrite this equation as minus 4 plus minus square root of we write this 48 as 12 times of 4, and here we write the square root of minus 1. And now we separate this fraction, and we write this 2 separately on both of these terms, so that here we get our y equals to, these are cancelled by each other, and we get here minus 2 plus minus, here we know that the square root of 4 is equals to 2 into square root of 12 divided by 2, and square root of minus 1 equals to iota. So here finally we get the value of y is minus 2 plus minus square root of 12 into iota. So this is the value of y, and now we back substitute the value of y here. So we have the value of y is 2 to the power of n. So now in order to find the value of n, here we need to take the log on both of the sides, so that when we take a log on both of the sides, it is written as log of 2 to the power of n equals to log of minus 2 plus minus square root of 12 into iota. So here we use the property of log, and we move this n in the front of this log, and it is written as n times of log 2 equals to log of minus 2 plus minus square root of 12 into iota. So here we move this log 2 to the right hand side, and it is written as n equals to log of base 2, and its exponent is minus 2 plus minus square root of 12 into iota. So these are the two complex roots of the given equation, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.